our brains as architects, that doesn't scale alongside, right?
Yeah.
So we need to kind of like find good ways and how we can navigate that landscape. So, I don't know if you have heard about that, but there's something like Conway's law happening in practice, right?
Yeah.
It has a history track record, I think.
Would you explain to our listeners what the Conway law is?
It is about the effect.
So, welcome to Blackbox Debugged, the Lufthansa Systems podcast. I'm your host, Dzefris, and today's topic that we'll be debugging is software architecture. Our guest today is Michael Wilmes, the lead architecture consultant, and he'll be helping us in debugging. Hi, Michael. Welcome.
Hello, Dzefris. Thank you for inviting me.
Thank you for coming. Will you please tell us something about yourself?
Yeah, I'm the lead architect in the architectural enablement team inside of our Technology Center of Excellence at LSY. And we are kind of like an inwards-facing consulting team. So we are supporting our products at LSY on their way with architectural challenges.
Awesome. What have you seen change over the years in the architecture domain, or in the specifically software architecture domain over the past 10 or more years?
I think we are today looking at a vast and comprehensive solution landscape. And that is quite natural, right? Like over the years, you expect the technology spectrum to evolve over time. And today you have choice, you have ample of choice. At university, you learn about SQL, for example, right? And nowadays we talk NoSQL in addition to it, or not only SQL. Or if you think about how systems communicate, right? We all were learning messaging, for example, right? Nowadays you talk about event-driven systems and architecture for that matter. And I think with that ample of choice, also the architectural role needs to adjust to that, right? So with that ample of choice, you need to navigate the solution landscape. You need to assess the situation, like when do you keep it with like regular architectural building blocks, and where do you actually go the extra mile and you say, okay, this is where it really matters, where I need to adopt maybe a newer technology, something that has been coming around lately, but with the potential to really bring you forward. So I think with that ever-evolving technology landscape, the role of an architect gets more comprehensive. And now that you factor in maybe AI for that matter, of course that is even more influencing that.
Interesting. I mean, you mentioned AI, but what I have come across, at least in my experience, is that very often as architects, people focus a lot on the system design itself. However, there are people, developers, who are building the system, and they are organized in a certain way. Could you help us understand better how socio-technical aspect of the software architecture impacts the design of the systems, or overall, does socio or social part in the socio-technical aspect of architecture design matters?
Yeah. I think when you look nowadays into what brings your IT system forward, then you're looking at it also from additional different perspectives, right? So, of course, you need to know as an architect, like, when is one fits all maybe not the right thing to do? When doesn't it cut it, actually? But you also need to elevate your perspective there and say, okay, what does really support your IT system from a human perspective? And that means you change the perspective, you're looking at it from a different ground, and that is factoring in the human factor. Or let's say, put it differently, the influence of the human factor and the team on your IT architecture. And you can imagine that with something like, you would say it's like an impedance match. For example, you have a music system, right? You have an amplifier, and the amplifier might be rated at 100 watts at 8 ohms, right? But then you have speakers which are rated at 4 ohms, right? And that is the impedance, right? You need to match it. Otherwise, your music system will not properly work. You will not get the best out of it. In the worst case, it has a damaging effect. And looking from that perspective, there are certain matches you need to watch out for. The first thing is all of the IT systems start with a business problem, right? You want to solve something for your business. And that is where you want to derive from the business capabilities a coherent part in your system that is a subsystem. And there are certain methodologies for that, right? We have, for example, in our toolkit as an architect, we have strategic domain-driven design. So that can help you in bringing down business capabilities into manageable parts of your IT systems, right?
Yeah, I mean, you mentioned domain-driven design. I've heard it in different contexts, right? As you mentioned, so the design of new systems, I think that's definitely somewhere where it could help us maybe avoid some of the traditional issues of the software industry, right? So we have been building software for quite a long time now, and especially, let's say, modern software in 20s now. That software was built in at the beginning of 20s. It's way over complicated these days, and also a lot of it is also legacy, large legacy systems. Can domain-driven design also help in that case as well?
Absolutely. It is finding these digestible parts from the overall scope, right? If you start with something fresh, right, you have a fresh business that you want to back with an IT system, you can start, for example, with event storming, trying to understand what should happen or what happens inside of your business, and then finding, let's say, boundaries on where you then try to find the first candidates on what you say is a coherent part of an overall system. Domain-driven design, the strategic part of domain-driven design, calls it bounded context. But then if you look at a existing system, maybe a system with a long history of it, like maybe 10, 15, 20 years old, which maybe comes around as more like a monolithic artifact, you want to identify, again, coherent parts of things you can put to the side and then extract from the bigger thing. And how would you approach that, right? You could randomly try to pick something you can grab and hold on to, and then try to pick something else, right? But chances are that maybe if you do it like that, there are dependencies pointing back from the thing you put to the side. Everything points back into the big monolithic existing systems. So the quest is still the same. Like, what are the coherent parts, and how can you identify what it is and what you want to put to the side? It should have a chance afterwards to be standing on its own feet. And that is where the strategic domain-driven design methodology really can help you getting there.
Interesting. And would you say that domain-driven design is a silver bullet to design better architecture, or is there something more there?
While it's always nice to find silver bullets, I think it's really hard to find them in practice, right? There is no silver bullet. And the same holds true for strategic domain-driven design. There's also the second part, like tactical patterns, tactical domain-driven design. It is like not a one-off exercise. The strategic domain-driven design wants to bring down from flight level 100, bring down your business capability into a coherent part of a system that you call bounded context that you can then back by a team and then let the system be developed in a loose coupled form or fashion. And one of the main ideas of domain-driven design is in that it bridges between the business side and the development organization, right? So when you do these things like strategic domain-driven design, I would highly recommend to always have both sides present at the same table at the same time. So it's your business side and your architects and engineers sitting in the same room at the same table. And then you want to get out from that with a consensus, right? That everyone looks at these coherent subsystems and says, okay, this is it. This is like what we can put to the side. It has a valid chance to live alongside autonomy. It's loose coupled to the rest of it. And it's derived from a business capability that it supports, that it backs.
And how do team topologies fit in this whole area of domain-driven design and the I assume social aspect of the architecture?
So when I initially talked about impedance matching, right, I should have said it's like actually multi-stage impedance matching, right? We just talked about strategic domain-driven design, mapping your system to your business capabilities as best as possible. Then, once you have these domain-driven design called the bounded context, you want to, again, have it backed. This time, it's about the human factor. It's about the team backing the bounded context. And that means you want to ensure that you don't do anything wrong here, right? That your desired architecture that you basically scratch the surface with by identifying a bounded context, that it goes berserk by maybe not having a good, properly fitted backing by teams, right? For example, if a bounded context is found to be, I don't know, in practice owned by multiple teams, right? Chances are that the autonomy that you intended to end up with your bounded context, that it maybe doesn't really work the way on how you intended it. And that is where team topology says, okay, you matched basically your system to your business, now match your team to your system. So I don't know if you have heard about that, but there's something like Conway's law happening in practice, right? It has a history track record, I think.
Could you explain to our listeners what the Conway law is?
It is about the effect on the way on how your organization works that is having an imprint on your system. Right, and that is inevitable to some degree. Like originally, it was phrased a bit differently, but I think today's consensus is that there is a quite noticeable effect, right? That once you have a good plan on how your IT system should be looking like, if your organization is working in different ways, not supporting this, then that your architecture eventually or your system will beginning to start looking like the way on how you're organizing. There's also a bit of a human factor in that as well, right? If you have one system and you give it to 5 teams or something, there is a slight chance that these 5 teams will be working towards maybe having this split it in the first place, right? So there's a tendency at least. And then the question is, if this is proven, then what do you do with it, right? You can say, okay, Conway's law, I don't believe in it, right? Whatever, regardless on how we organize, we can still build straight architectures that completely look different to maybe how we do things organizational wise. You can also say, okay, I'm accepting it. I'm trying to counteract, right? I'm trying to save the day. I'm aware of Conway's law, and I'm trying to control myself as my IT system evolves over time, as I'm designing it, as I'm architecting it, building it, operating it. Then there's also another possibility there, in that you say, okay, I'm not only accepting Conway's law, but I actually want to apply the reverse Conway law. That is where you say, okay, this is my desired architecture, right? I map this to my business. I know that this should have a chance to be something of a coherent item. Let's actually design my teams to match the architecture that I want. And that is something of a quite influential attempt. And that is where team topologies comes in, where they say, okay, how can you best back what you, for example, derived from domain-driven design? How does an organization nowadays need to look like to best back your desired architecture, your desired IT system? And that is then coming into let's say an artificial limitation. It's not everything in team topologies is completely hasn't been there before, but it's a very concise, digestible, let's say, assortment of best practice and nailing it down for making a difference for when you're designing your teams around desired or existing IT systems. And team topologies, as I said, is like an artificial constraint, let's say. Some people say that, in that you only have 4 team types.
Yeah.
Right? They say, okay, try to organize, try to identify how your team should be looking like and how they should behave in coherence with the rest of the team. And that says, right, for example, when you have a bounded context, that is like a business capability, then team topologies, for example, would call it a value stream oriented team. That is the first team type, right? They're building your feature, they're building this product. And then team topology said, okay, what else do you need? And then there could be some fancy algorithm, something that is really where you need very special expertise, and you cannot have it everywhere in the company. And that is then where you, for example, have a value stream, where you have a complex subsystem team, right? Which is maybe it is your AI experiment, your algorithm that the world hasn't seen yet. You can do this in a complex subsystem team that then passes the artifact as a service to the original product value stream oriented team. Then you have team topologies and domain-driven design and platform engineering. They're friends. All these concepts are friends. And they perfectly work in connection to each other. So when you then factor in and say, okay, if I slice vertically, right, I have this bounded context, I slice my product vertically, and I want these verticals to be empowered to have the autonomy and go towards mastery of their capability, you might end up to the point where then team topologies says, okay, how about cognitive load, right? It could be that your bounded context is a bit large. It could be that it is complex from the belief that you say, okay, be end-to-end responsible, right? You have a vertical, it supports a business capability. How can you support this value stream-oriented team doing it end-to-end without beginning to, again, slice it horizontally and give it away to others? And that is where then platform engineering and other concepts say, okay, you can have those teams be helped by platform teams, right? And when we look at these concepts, they basically define the platform enablement factor pretty much similar, right? So you can say, okay, what does a platform do? they help lowering the cognitive load of value stream-oriented teams. And that then empowers the value stream-oriented team to still be end-to-end responsible for their services. And then, lastly, there's the enabling team. And I am actually part of an enabling team. And that is like really empowering the other teams in certain topics that they need. Like empowering in terms of architecture is for example, my team's purpose, but there can also be enabling teams focusing on different characteristics that you feel missing in your organization. You want to support knowledge build-up, for example, right? Incentive initiatives. And then your organization can say, okay, can there be a team type that helps other teams, but without taking over the steering wheel? Because again, you want these value stream-oriented teams, the teams who build the product. You want a certain autonomy with them to really be able to optimize the flow.
It's really fascinating, or I find it fascinating that even if you set a target architecture, but you do not organize well the people that are building that system, that software system, or any kind of system, the system will end up looking different than what the target architecture that has been planned or set previously, right? We talk now a bit about how to organize teams and how to maybe design on a high level the system better from the domain-driven design perspective. Could you pick a couple of the evergreen technical patterns that you could say, hey, these are the ones that are like applicable across the board? Of course, there are many different domains and many different specific cases where certain patterns should be used, right? Otherwise, they become anti-patterns. But maybe if you can pick a couple of them that are the ones that you saw through your experience that are very useful and can be applied across the board.
I mean, when you're an architect, or I think the same holds true for engineers and developers, is at some point you'll start seeing patterns everywhere. And that's good, right? I mean, that is really like helping us as IT organizations to getting something actually built, right? We don't want to every time like really reinvent the wheel, and patterns really give us reusable ideas in how to address typical architectural problems, right? They don't specifically tell you how to do it from implementation perspective, but they really tell you with this idea you can address this architectural challenge. And that is why patterns for us in the IT industry are super greatly important. And I think at some point, as I said jokingly, you see patterns everywhere. It is not only like detectable in, let's say, programming or something, right? For example, if you have a proxy pattern, like proxy pattern for the ones who do programming, right? They see it, right? You have it in Java, for example, in Spring, right? If you have a cacheable annotation, if you have Spring Security or something, you have these annotations. What happens behind the curtain is you're actually creating a proxy that acts on behalf of what you originally have in this code, right? And then you can actually add something on top. And in this case, you can make something cacheable that wasn't cacheable before. You can add some security feature. You shield something from the outside that wasn't shielded before. And when you look beyond programming, then you see again proxy patterns, right? Because we have, reverse proxy. Everyone knows what a reverse proxy is, right? And API gateway or service mesh, envoy proxy. So all that is, again, the same applied pattern, of course, for different use cases, but the problem in itself is the same. Or there are even more exotic ones, dependency injection, for example, right? Where where, of course, when you do programming, you want to have your code reusable, right? You're using dependency injection. You can, at a certain point, swap implementations for maybe a mock or a test, right? You want to test your stuff properly. You likely need to have dependency injection. But then if someone in the industry on an event says, our product comes with batteries included but swappable, then basically the idea is kind of like the same. And that, I think, helps us as architects in navigating the whole solution landscape, right? And we talked about in the beginning of that podcast about the impressive amount, the vast solution landscape that we are having, right? That is ever growing more complex, right? And our brains as architects, that doesn't scale alongside, right?
Yeah.
So we need to kind of like find good ways in how we can navigate that landscape. And seeing these patterns helps you then in saying, okay, what does this solution actually do? Like, what does it do if you put away all that marketing stuff, like that high gloss stuff, right? If you see underneath, and then you see, okay, this is like the pattern that it does effectively, you can then better compare it with other solutions, or can maybe assess the approach, right? Maybe another pattern would be better suiting your architecture. And then you first look at the pattern, and then you look at a solution. And that gives you also a bit of a safety there as an architect to not be completely distracted by, of course, in the industry, everything is gold, everything is possible, 1,000 ways to roam. That I think gives you a bit of a peace of mind in still being an architect that can navigate these waters.
Yeah. There is something new that it became popular, at least in this century or very recently, specifically LLMs in the whole domain of AI. So what I'm talking about is the ideas of AI started in the last century as well, but they became quite popular now with the introduction or wide adoption of LLMs or GenAI in the software industry overall. And this is something that we cannot avoid, of course, as architects, nobody can actually avoid it. And we'll probably talk about it in almost every other podcast, episode we have, because it touches everything these days, right? It touches security, it touches the architecture, software development, and customer service, project management. Pretty much it's everywhere, right? There are like solutions that are be proposed, like I think everyone is figuring out where it can be used and what's the best solution application of it. My question would be, what's the challenge? What's the challenge for the architects in this age of Gen AI? What
how
do you
shall I
see?
start? Like, it's inevitable, right?
Yeah.
Like we definitely need to talk about that. And I think with Gen AI, it's a bit like little cats are now out of the box, right? And they will roam around freely, and we like them roam around freely, but of course they will really be a challenge to us, right?
Yeah.
It is very young age in that regard. Like, of course, the basics of what we now see with Gen AI, that is, of course, dating way back, but the thing is now the availability of it, right? That it's really omnipresent, available to us in the toolbox, right? We're getting really bombarded with this kind of features now that is available to us. But on the other hand, it is also a bit of like a gold rush or gold digger phase of a new era, right? And that is, I think, definitely super disruptive. It is having a very high enablement factor, right? You shall not ignore it. You definitely need to be at that party. But on the other hand, a smooth sailing, it is not yet, right?
Yeah.
Like hardly anyone is monetizing AI as of today. It is a challenge also for us as architects, right? And we have new terms even popping up, new patterns, right? We talked about patterns.
And a lot of buzzwords.
Yeah,
as well
absolutely.
Around, yeah.
Like, is it cloud LLM, right? And then comes, I don't know, local LLMs, right? And then, you can run it on your device even, right? And then, I have a MacBook and, LLM runs on my MacBook. But then someone talks about hybrid eventually, right? That some stuff is running on your notebook, when then some prompts go to cloud-based LLMs, then you have the thing about long context, right? Like versus RAG. Then some people say, is it actually versus, right? Or isn't RAG benefiting from a long context? So we as architects need to come to an opinion about that. It's not always this or that, but there's also sometimes a valid combination, or one is actually enabling the other. Or model context protocol is something that has been pretty high on the rise for the last couple of months. And MCP, then agent to agent, right? And these are revolutionary, right? We didn't have these things in the past as architects, and this thing gets now even more delicate, right? If you like 1.5, 2 years ago, the LLM, the large language model, was kind of like a sandbox, right? You can ask it, you can maybe properly prompt it, so you get a better experience out of that. But now you give the artificial intelligence hands in the real world, right? You give it tools. You're bridging the gap between artificial intelligence and reality. And then you even let agents talk to each other, right? Agent-to-agent protocols. Yeah. So that is quite something that is as new and fresh and empowering, but also as it is having very rough edges. So, for example, MCP, the Model Context Protocol, of course, right? When Anthropic gives this out to the masses, right? This is a protocol, right? There's a certain way easifying the things. These things pop up everywhere, right? You have MCPs for controlling YouTube. You have MCPs for going after Jira or Confluence, right? They can make new tickets for you, right? You're exposing these actual real-world tools to your LLM at the disgrace of the LLM, right? So the LLM can decide on whether it actually invokes your tools to have it presented. And that is tricky.
That's tricky. And I mean, there are parts where also, like, I think recently there were some figures published by also OpenAI where they're stating that it cost them millions to just run the model. Basically, not complete. Of course, it costs much more than millions to run all of the OpenAI public available chats, but it's just a couple of millions just for people saying thank you and goodbye to AI, right? And I mean, there are a lot of these like ambiguities, how to handle these certain things here. And my question there would be also from the architecture perspective, how do we fit then AI? How do you see what's the best way to fit the AI into the context of the system you already have, like the architecture? Do you put it on the side? Do you change your whole architecture just because of AI now? Yeah.
So first of all, I would say, like, there's also challenges for the architect in the age of AI, like especially when we now talk about LLMs. It's sometimes even the easy questions, like, okay, you're using a specific LLM version as part of your product, right? But is it guaranteed to be around in a year? Likely not, right? We have obsolescence management. I think obsolescence management is a thing in IT, of course, right? We always don't know, right? We strive to not be behind the curve too much, right? Technical debt management, for example. But the thing is, like, the LLM might not be around. Like, the thing you used might be outdated in half a year, right? You need to balance, like being able to solidly relying on a specific version of AI, right? Where you say, okay, I know I can trust it, I know what I get. Or do you say, I want to be like ever adopting the newer generation of LLMs, but you need to prepare your architecture for it. You need to prepare your organization to then be at the speed of development of LLMs and adjust accordingly, because every LLM will again be slightly different, like even if it is about the character, let's say, on how it replies to you. But there are even other implications, for example, security implications, right? When we cross the border from generative AI and give it actual tools to the hand, then we also need to be more careful about what we are enabling here, right? So, for example, there could also be security implications with some of the patterns that get introduced alongside generative AI. We talked about MCP, and sometimes you see these MCP servers now popping up. They have no authentication baked in, right? And they have no input verification, right? Something that we as software developers and architects know since ages, right? That you do not copy, paste, or reuse a user-supplied input and then actually execute something unvetted in the real life, right? Yeah. You usually don't do this, but yet we see this with new technologies, right? Everyone wants to be the first. MCP servers come up. You have a registry. It gets easy to use. But then these basic principles of architecture and software engineering are sometimes still missing from the picture. And then it's us as architects that need to check, do the check and balances here. Like, is it too early for us in our product? Do we adopt? But then we also feel ourselves entitled to add maybe the missing ingredients so that we can trustfully and reliably use it inside of our product. So that will be a challenge for us as architects going forward. It's a very fast spinning wheel, and it's not a perfect round wheel, right? Yeah. You need to definitely walk the extra mile to understand it and maybe to add something on top to make it actually usable.
Yeah, this extra mile seems to be part of the software industry and our jobs as software developers and architects since the beginning of the inception of the industry. And it's been quite often, as I think previously mentioned, that corners tend to be cut here and there, and then this cutting of the corners accumulates over the time, and there is a name to that, how we call that. Can you, in short, just explain what is
technical depth? Is
yes,
that what
exactly.
you are saying?
Okay. Yeah, so
that's
technical
like,
depth.
That's really like the ever-going quest of a software architect is like having the technology depth not growing out of bounds. I mean, a certain kind of like being in depth when doing any kind of software development, I think you can take it for granted, right? With the first line you're committing to any repository, you're already going into depth, right? You're already kind of like behind the curve, right? If you always like update to the latest whatsoever of an upstream software version, you might be also having problems, right? You also don't want to be on the bleeding edge of things. So there's a fine line there, and the software architect's role is there to really have this in check. So if something becomes slightly smelling, there's a chance that the architect should raise a hand and said, you know what, we need to do something behind the curtain, right? We are falling behind. What at some point starts smelling becomes into something that maybe stinks at some point, right? So it is like an ever-going quest for the architect to go after technical depth before it renders your software to a situation where you are kind of like out of proper ideas on how to get away with it. Like your choice at some point gets vastly limited and that is something to be prevented with managing technical debt from an architecture's perspective.
Exactly, and I think now in this age of GenAI and generated code that is coming out of the models that were trained on all of the repositories, right? And a lot of repositories also out there on the internet contain a lot of not just legacy code, but also anti-patterns, technical debt. And then I think this is something also that we need to keep in check when you're using GenAI during the coding. Also, I've seen some examples out there where some architects were playing with GenAI, trying to generate some diagrams. And basically it generated ULM diagrams based on all of the not so great out there diagrams. And then if you don't check it yourself, and you could be then exploding your technical debt with GenAI, right?
Yeah,
so additionally, in combination, so it's not. I don't think it's getting easier. In some sense, it could, but it's I think getting even harder because now you're even less understanding what actually you're doing, right? There is always a bit of ambiguity in software when something is being done.
And that will be quite important going forward because I think generative AI will have it a bit easier on the productivity side of things than it is to really be part of products in a safe and sane fashion and being able to monetize or write on that promise, right? Where you say this becomes an essential part of my product. So people, of course, look to the productivity side. Developers, software engineers, architects, and the thing is, like, you need to treat that code like when you use LLMs for making your life easier, right? Is like a companion sitting next to you, helping you in implementation maybe of your software project. You need to treat this with a certain mindset, right? So it is really like a new pull request coming from the side.
Yeah.
It's not knowing anything of how are your policies in the company, what is the tendency, how would you like to have things looking like. Yeah. Of course, you can try to save the day with prompting, but at the end, you're the one on the line and saying this is your software product, your software, you own it, and there's no one else, right? So usually you would treat this generated code with the necessary degree of vetting, and that is an unknown colleague's pull request. You never saw him or her before, and treat it with the same kind of dignity and say, okay, yes, cool, nice code, but actually we need to thoroughly go through it. And that is something, of course, we did it back in the days when we had Stack Overflow, right? I hope that we didn't copy paste from strangers from Stack Overflow. We let ourselves be inspired and be helped by suggestions, but then we went the extra mile on actually making it our own vetted code inside of our software project.
Yeah, it's fascinating. Let's see how this is gonna develop. And I mean, even though we do a lot of vetting during the software development processes, right? During the design phase or during the requirements phase and the design phase and the development phase and the testing and so on and so on and so on. Still, sometimes certain things sneak through and that happened in the past, that happens these days, it will happen in the future, right? As the last question for today, I would like to ask you, could you share with us one single most bizarre architecture decision you came across that really
that's a good one.
That really sticks out.
Yeah, I think it was 2017 or something, and that was having nested virtualization in an already virtualized environment. And I think in the end it turned out just great. But from an architecture design perspective, that was kind of like really extreme and bleeding edge at that time. And I think Microsoft announced nested virtualization just a few weeks before that decision was been made, and I would consider that quite
bizarre.
Quite bizarre, but at the end, I think
it's a still running system, right?
It's still around.
Okay,
and it pays back. So that was I think a proper decision making, even if at the time I think it looked a bit bizarre.
Yeah, interesting, really interesting. So nested virtualization. Michael, thank you very much for joining us today in debugging of software architecture. It was really a pleasure talking with you, and we look forward to having you sometime in the future.
All right, thank you for inviting me, Dzefris.
Thank you.